One of the most essential mysteries of the universe that science has not yet been able to solve is whether life exists anywhere else in the universe besides on Earth. Scientists have tried to answer this question for years without a clear answer. There could be life out there, but if that's the case, why haven't we found it yet? If life is something normal in the universe, where is it? Why haven't we found other planets full of life like Earth? Why haven't we received radio signals from other civilizations? Or could it be that, on the contrary, life is something extraordinary and complex, and all the life that exists in the entire universe is found on Earth? The Berserker Hypothesis and the Dark Forest Theory. Are we alone in the universe? Since we began exploring the solar system and observing the universe with telescopes, scientists have asked themselves, is there life out there? Although the universe is immense and the number of places where life could exist is immeasurable, we have not found another place outside our planet where living beings exist. It is as if life were something elusive to Earth. But when we start to analyze things carefully, some essential questions arise, such as, why did life emerge on Earth and not elsewhere? What is unique about Earth? Before, we believed the Earth was an oasis, a world like no other, with unique characteristics that cannot be found anywhere else. Still, since we discovered that the stars are solar systems like ours, and that each star in the universe has planets, this belief stopped making sense. As of the creation of this video, we have discovered more than 5,000 exoplanets in our stellar neighborhood alone, at least a third of which share many characteristics with our planet. Even the most conservative studies indicate that the Milky Way could host up to 6 billion Earth-like planets. That is to say, if we talk about unique things, the Earth does not seem to be a unique place in our galaxy. It is illogical to think that all the conditions that occurred on Earth could not have also occurred on some other planet in some other galaxy, from any other part of the universe. Statistics favor logic. Everything tells us that the probability of there being another planet like Earth out there is very high. If we talk about life, we come across the same problem. Every living being that inhabits our planet, from the most modest bacteria to one enormous whale, is made up of practically the same thing, CHON. Carbon, hydrogen, oxygen, and nitrogen are the four most abundant elements in a living being. More than 96% of one adult human are made of those four elements: 65% oxygen, 18% carbon, 10% hydrogen, 3% nitrogen, and the other 4% are traces of other elements such as carbon, phosphorus, and sulfur. All these elements are formed in the final stages during the death of stars and released into planetary nebulae that form planets rich in these elements. In other words, life is not made of rare, complex, or unique materials. The ingredients to make a living being are relatively easy to find anywhere in the universe and are extremely common. Furthermore, according to probability, there are hundreds of thousands of Earth-like planets where there will surely be elements like those here. So if life is something that does not require complex materials or special planets, why isn't the universe full of living beings? Why does it seem like we are entirely alone and that there is no life outside of Earth? This is known as the Fermi paradox and the grand filter theory. The Fermi paradox consists of the apparent contradiction between estimates that there is a high probability that other intelligent civilizations exist in the known universe, and the absence of evidence of such civilizations. The great filter prevents life from emerging from inert matter, and eventually an intelligent civilization like ours. The idea suggests that in some stages of the formation of intelligent life, something suddenly stops the development of said civilization and completely extinguishes it. For example, human civilization has existed in the universe for only 2.5 million years as a species. But the most significant scientific and technological advances have occurred in the last 100 years. Among these advances is the technology that we have managed to develop to self-destruct us, the nuclear weapons. Currently, the nuclear arsenal in the world is enough to eradicate the entire human race. If this is the great filter that great civilizations cannot pass, it means that humanity is close to exterminating itself, and with it, all living beings on the planet. This would also indicate that we have not found other advanced and intelligent civilizations like us, because the same thing happens to them too. It's as if once a civilization discovers how to create atomic bombs, and they fail to contain their desire to use them and end up self-destructing in a senseless nuclear war. The interesting thing is that even if the human race became extinct due to a nuclear war and we devastated the entire planet, there was no way we would be able to exterminate all life forms on Earth. Throughout history, our planet has gone through much more devastating cataclysms than a simple nuclear war. Even a species as violent as humans cannot exterminate all living beings, since in the darkest corners of the caves or in the deepest crevices of the ocean, bacteria and other microorganisms that have been on this planet for billions of years would survive, resisting everything. These ultra-resistant life forms will undoubtedly survive any nuclear war. It may take hundreds or billions of years, but life will prevail even if humans destroy everything. As the years go by, the radiation would dissipate in the environment. New life forms would populate the world again, evolving to adapt to each planet's ecosystems. Some of these new species may develop great intelligence again and be the planet's new ruler. Life seems to be something very resilient that expands to fill all available ecological niches and that cannot be exterminated so easily. On our planet, life will continue to exist no matter what we do. The only thing that can change that is our star. When the sun runs out of fuel and dies, life on Earth will too. Meanwhile, no matter what happens, whether a meteorite falls or a race of intelligent apes destroys the entire surface with nuclear bombs, life will always re-emerge among the ashes, and it will evolve to adapt to all ecosystems on Earth. Suppose this scenario is similar to other planets in the universe. In that case, it means that if life also emerged on another planet very distant, billions of light years from Earth, these life forms are still there waiting to be discovered, or have even evolved to such a degree that they are also looking for us. So why haven't we found them? For years, scientists asked themselves these questions, and thanks to this, we arrived at different hypotheses, which we will talk about. The Dark Forest. The Dark Forest hypothesis is that there are many alien civilizations throughout the universe, but they are silent and paranoid. This is explained so that any spacefaring civilization would view any other intelligent life as an inevitable threat and destroy any nascent life that makes its presence known. In other words, if a civilization is aware of its ability to destroy other living beings, it will believe that the rest of the civilizations are also just as dangerous as them. Therefore, it is best not to contact them, since they would enter a war where both of them fight and are destroyed. As a result, all civilizations would eventually learn to hide, and the electromagnetic spectrum would be relatively silent, with no evidence of any intelligent extraterrestrial life, as in a dark forest full of armed hunters lurking among the trees like a ghost, observing without being observed. This would explain why, although we searched for signatures of life throughout the universe, we found nothing. Maybe it's because we're the only ones looking and no one emits detectable signals. Berserker Hypothesis. In the context of extraterrestrial civilizations, there is a type of spacecraft called von Neumann ships, also known as self-replicating spacecraft. This type of spacecraft, as its name indicates, is characterized by being a spacecraft that can collect materials from any celestial body to create more copies of itself, imitating the operation of an intelligent 3D printer that would be able to make predetermined decisions programmed so that when it finds a celestial body with valuable materials, it would simply land on that body and begin mining it to create more copies. Given this behavior and its similarity to the reproduction pattern of bacteria, several authors have expressed that von Neumann machines could be considered a mechanical, not biological form of life. In his short story, Lungfish, David Brin touches on this idea, pointing out that self-replicating machines launched by different species could compete for the materials of celestial bodies. Given a sufficient variety of species, they could even form a type of ecology, or if they also had some form of artificial intelligence, a society. In this way, the ships could mutate over thousands of generations, slightly changing the objectives for which they were initially programmed. There are many variants of self-replicating ships, but the topic that matters to us today is the Berserker ships. These types of spacecraft are a variant of the von Neumann probes, programmed to search for and exterminate life forms and exoplanets capable of supporting life as they are detected by these spacecraft. The Berserker hypothesis arises as a response to the Fermi paradox. It explains that if humans have not yet detected intelligent extraterrestrial life in the universe, it is because it has been systematically destroyed by a series of lethal Berserker-type von Neumann probes that were created by an extraterrestrial life very ancient and programmed with the sole purpose of exterminating all traces of life in the universe and then self-destructing once they've wiped out life on that planet. In his 1983 article, The Great Silence, astronomer David Brin summarized the terrifying implications of the Berserker hypothesis, saying that it is fully compatible with all the facts and logic of the Fermi paradox. Still, it would mean that no life left intelligent to discover exists, since the probes have been responsible for exterminating all life forms in the galaxy as they appear. In the worst case, humanity has already alerted these ships of our existence, and we are the next to be destroyed. Something interesting about these types of spacecraft is that the race that created them probably no longer exists. However, the ships they created continue replicating themselves, exterminating all life forms in the universe, causing terror even when their creators disappeared millions of years ago. Berserker probes exist? A vital component of the hypothesis is that a Berserker probe has not yet visited Earth's solar system. A 2013 analysis by Anders Sandberg and Stuart Armstrong at the Future of Humanity Institute at the University of Oxford predicted that if a small fleet of Berserker probes were able to destroy civilizations elsewhere, even very slowly, they would most likely have encountered Earth by now and destroyed all traces of life millions of years ago. In 1981, Frank Tipler proposed that if we assume even a moderate rate of replication in the history of the galaxy we live in, self-replicating space probes should already be seen in space, and thus we should have found them by now. But because we have not found them, this shows that extraterrestrial intelligence does not exist and that we are the only intelligent beings in the universe. Another answer to the Fermi paradox is that we are first. Suppose the human race is the first species to have this degree of intelligence and technological advances. In that case, no matter how much we look for other extraterrestrial species, we will not find them since they still do not have telecommunications technologies and are unaware of radio waves. If this is the case, we will have to wait several hundreds or thousands of years to detect the first signs of another intelligent civilization besides us. But in the end, the last answer lies with you, our viewer. We want to know what you think. The rare earth hypothesis. Basically, according to this hypothesis, life and the evolution of complexity require a combination of astrophysical and geological conditions that are simply not common in our universe. In other words, we are quite special and unique. If this hypothesis was true, we would be in a real messy situation. Astronomy and mostly cosmology today assume the prevalence of intelligent life in our universe because we think the universe is isotropic. For isotropy, we mean that the universe is the same in all directions, on a macroscopic scale. You can understand isotropy thinking of a sphere. If you are at the center of this sphere and you point towards different directions, nothing changes. All of this is also consistent with the Copernican principle, which argues that if something is randomly sampled, it is likely to be representative of the majority. If we translate this in the astronomy and cosmology field, the Copernican principle is telling us that Earth-like planets are common in our universe. We need such an assumption. We need the Copernican principle because if the universe wasn't isotropic, it would be very dangerous and actually almost impossible to make quantitative studies of the objects we observe, such as galaxies, stars, and planets. We needed to set up our mathematical understanding of the world. If the Copernican principle doesn't hold, then Earth is actually not representative of the whole and is in a class reserved for very few planets. Maybe Earth is an outlier. Given the fact that we haven't found any evidence of extraterrestrial intelligence in the universe yet, wouldn't this seem like the more plausible scenario?
The rare earth argument is based on two hypotheses. The first one is that microbial life is common in planetary systems. The second one states that advanced life is rare in the universe. If we combine these two hypotheses, we understand that Earth-like planets may evolve from a series of events and circumstances that are quite rare, making Earth a very special place. This argument was in response to the inherent assumptions and biases that were identified in the Drake equation, which essentially asserts that intelligent life should be plentiful. For example, Ward and Brownlee, authors of the book on Rare Earth Hypothesis, wrote, "They also say life originated here about 4 billion years ago and then evolved from single-celled organisms to multicellular creatures with tissues and organs, climaxing in animals and higher plants, and then ask themselves if this particular history of life, one of increasing complexity to an animal grade of evolution, is an inevitable result of evolution or even a common one. Maybe it could be just a rare combination. Mathematically, the Drake equation can be expressed as a product of various factors. N is the number of civilizations in our galaxy. R star is the average rate of star formation. Fp is the fraction of stars that have planets. Ne is the number of planets that can support life. Fl is the number that will develop life. Fi is the number that will develop intelligent life. Fc is the number of advanced civilizations, and L is the length of time that these civilizations would have to transmit their signals into space. This equation aims to compute the number of civilizations in our galaxy. Of course, the more we study and understand the universe, the more precise are our constraints on the factors. For example, astronomers now estimate that there are between 250 and 500 billion stars in our galaxy, which forms new stars at a rate of about 3 solar masses per year. The discovery of over 4,000 extrasolar planets in the past few decades has also allowed astronomers to get a much better sense of how many stars have planets and the number of planets that are likely to be habitable. In fact, based on Kepler data, a study conducted in 2013 estimated that there could be as many as 40 billion Earth-sized planets orbiting in the habitable zones of their stars, 11 billion of which would be orbiting Sun-like stars. Nevertheless, there is still a great deal of uncertainty in the Drake equation, especially when it comes to the emergence of life, at a rate at which life will rise to intelligent life and everything that follows. But as we said, Ward and Brownlee were skeptical about Drake's theory. That's why they presented a new version of the equation in their book. It looks pretty much like this. Here, N star is the number of stars in the Milky Way. Ne is the average number of planets in a star's habitable zone. HZFG is the fraction of stars in the galactic. HZFP is the fraction of stars in the Milky Way with planets. FPM is the fraction of rocky planets. Fi is the fraction of habitable planets where microbial life arises. Fc is the fraction of planets where complex life evolves, and there are a lot of other parameters that we have to take into account if we want a good estimate of N. They even try to take into account the extinction events that could happen during the evolution of an intelligent species. Like the Drake equation factors, these are also subject to constraints and uncertainties. But using Earth as a template and employing the Copernican principle, it's easy to see how it would be difficult to find planets that meet all of the above listed criteria. Ward and Brownlee also listed other factors that were peculiar to Earth and are believed to have contributed to the emergence and evolution of life. For example, there's the presence of plate tectonics, which have been fundamental to climate stability here on Earth. And they also cited geological evidence that indicated that twice in our planet's history, the Earth was very cold and covered in ice. This is what astrophysicists call snowball Earth epochs. These epochs occurred roughly 2.2 billion and 635 million years ago, both of which coincided with key developments in terrestrial life. The latter snowball period coincided with the Cambrian explosion, 570 and 530 million years ago, which was characterized by a burst of species diversification and the appearance of almost all animal lineages that exist today. In other words, key events in the evolution of life on Earth appear to have followed a snowball Earth period. North Sentinel Island is a place where a tribe that separated from the rest of civilization more than 60,000 years ago and who are currently studied from a distance as if they were a zoo. But just as we study the inhabitants of North Sentinel Island as if it were a zoo, would it be possible that an extraterrestrial race much more advanced than us could be studying the human race as if we were a zoo? North Sentinel Island. North Sentinel Island is a small island in the Bay of Bengal in the Indian Ocean. This island is a part of the Andaman Islands archipelago, which belongs to India. What makes North Sentinel Island unique is that it is inhabited by an indigenous tribe known as the Sentinelese, who have lived in isolation with virtually no contact with the outside world for approximately 60,000 years. In theory, the island belongs to the administrative district of South Andaman, part of Indian Union territory of the Andaman and Nicobar Islands. Still, the Indian authorities recognize the islanders' desire to live without contact with the world. Indian laws do not apply to the Sentinelese, who manage their affairs internally. Therefore, the island can be considered a de facto sovereign entity under Indian protection, since the Sentinelese themselves are unaware of the existence of said country and their membership in it. Given that the Sentinelese do not, in practice, carry out any customs activity or maintain relations with anyone outside the island, these powers that India assumes are more theoretical than real, since the island's inhabitants have never agreed anything with anyone. Sentinelese tribe is known for their hostility towards outsiders and their resistance to any form of outside contact. They have rejected attempts at rapprochement by explorers, fishermen, and Indian authorities on numerous occasions. The Indian government has established a policy of voluntary isolation and protection of the Sentinelese to preserve their culture and protect them from possible diseases that could devastate their population, since they have no immunity to common diseases such as flu or measles. Due to the danger of approaching North Sentinel Island and the established isolation policy, the island is one of the world's most inaccessible and mysterious places. Access to the island is prohibited by law, and Indian authorities have implemented an exclusion zone to protect the Sentinelese and anyone trying to approach. Why has it been decided to leave this tribe alone? It has been decided to leave the island's inhabitants alone because any contact with modern civilization could pose a mortal risk for them and anyone who tries to approach them. Throughout history, there have been various encounters with the inhabitants of the island. Some of them are: in 1880, the British ship Rifleman approached North Sentinel Island, and the ship's captain left gifts on the beach before departing. Later, a group of Sentinelese were seen breaking up and squashing the gifts, suggesting that the gifts were not accepted. 1896. The British government sent an expedition led by Maurice Vidal Portman to try and establish contact with the Sentinelese. The expedition was essentially a failure and resulted in the capture of several Sentinelese who were taken to the main island of the Andamans. However, the captured Sentinelese soon fell ill, and it was decided to return them to their land of origin. 1970. During the 1970s, Indian authorities made occasional trips to North Sentinel in an attempt to gain friendship of the tribe. They were usually organized at the request of leaders in search of adventure. On one of these expeditions, they left 2 pigs and a doll on the shore, but later the Sentinelese hunted the pigs with their spears and buried them along with the doll, indicated that the gifts were not accepted. These visits became more regular in the 1980s. The teams tried to land in places out of reach of the arrows and left gifts such as coconuts, bananas, and pieces of iron. Sometimes the Sentinelese seemed to make friendly gestures. Other times, they would take the gifts into the jungle and then shoot arrows at the group, trying to establish contact. Apparently, in 1991, there seems to have been a breakthrough. When the researchers arrived at North Sentinel, the tribe signaled for them to bring them gifts, and then, for the first time, they approached without their weapons. They even got into the water and approached the boats to collect more coconuts. However, this friendly contact did not last long. Although the gift-bearing trips continued for some years, the encounters were not always friendly. Sentinelese sometimes pointed their arrows at the group, trying to make contact, and on one occasion they attacked a wooden boat with their adzes, stone axes for cutting wood. No one knows why the Sentinelese abandoned and then resumed their hostility towards contact missions. Still, many researchers think it is likely that after the first approach, Some Sentinelese fell ill and died from catching the flu or measles, causing the islanders to distrust the gifts and to return to their rejection and hostility. In 1996, regular gift-giving missions were ended, as many researchers began to question the logic of trying to contact people who are healthy and content and have had lived prosperously independently for more than 55,000 years. Friendly contact alone had devastating consequences, and prolonged contact with the Sentinelese would almost certainly have had tragic consequences. In subsequent years, only occasional visits took place. After the 2004 tsunami, researchers made 2 visits to verify from a distance that the tribe appeared to be healthy and had not suffered in any way from the ravages of the tsunami. They also confirmed that the hostilities continued because when they flew over the island by helicopter, they were greeted with arrows from its inhabitants. India then declared that it would not attempt new contacts with the Sentinelese. North Sentinel Island and its inhabitants, who have evolved wholly isolated from the rest of civilization, do not want or need to establish relations with us. However, even though they don't want to know anything about us, we do want to know a lot about them. A human zoo? It is likely that among the island's inhabitants, some curious people wonder where those men come from who dress in such colorful clothes on those boats that can cross the ocean. The Sentinelese cannot produce fire, but it is known that they can manipulate it. When lightning strikes and produces fire, they can feed it and maintain it for long periods, but once it goes out, they cannot generate it again. Perhaps after many years since the last contact with our civilization, the youngest members of the island occasionally see lights in the distance from passing boats hundreds or thousands of kilometers away, and wonder how we can catch the sunlight in small spaces to illuminate us at night. For decades, several boats were shipwrecked on the island, and most of them contained metal which today is known to have been used to make the tips of their arrows harder. This is somewhat paradoxical, since although we have made great efforts to keep the members of the island isolated from the rest of civilization, we have indirectly provided them with materials and technologies that in everyday situations they would never have. In the case of humanity, we first mastered fire and then began to produce metal from much more complex processes. Still, the Sentinelese are taking that path in reverse, having metal at their disposal without first mastering fire. We have unintentionally changed how they continue to evolve and how they see the world. The most curious members of the island may occasionally look at the sky to contemplate the stars, and are surprised that every so often a train of stars that move one after another cross the sky. And every day they also manage to observe much more colorful stars that blink and move quickly in seemingly random directions. They do not know that those strange stars are not stars but creations of humanity, specifically satellites and airplanes, technologies they cannot even imagine. We can photograph the island from space with artificial satellites, or observe it with binoculars, thanks to modern technology. We also have technology to listen to what is happening on the island and cameras to photograph what they do. In this sense, could we say that the North Sentinel Island is a human zoo? Although it sounds somewhat cruel, seen from a scientific point of view, it probably is, since zoos are places where a specific species is kept, isolated, and under observation, trying as hard as possible not to interrupt its natural behavior, or if possible, study it without them realizing it. The Sentinelese are humans isolated on an island that guards a nation, where we can't always know who enters and who leaves. We can observe them whenever we want and study their behavior all the time. Furthermore, they do not know that they are being observed and studied by us. So the question is, would it be possible that, just as we study the Sentinelese without them realizing it, an extraterrestrial race could do the same with humans without us realizing it? It may sound weird, but let's remember that there are many things in the universe that we do not understand. Our technology does not yet allow us to carefully observe what happens on each planet of each star in the entire galaxy. What if, on the other side of the Milky Way, there is a Type 2 alien civilization on the Kardashev scale that is currently in the process of becoming a Type 3 civilization, and has designated the Earth as a zoo to study life for billions of years. In this case, this civilization would have designated a sector of the Milky Way as a huge zoo made up of thousands of stars. All the stars in that sector, including the Sun, would be part of that enormous zoo, which is the property of this extraterrestrial civilization with technology to observe what happens on each planet simultaneously. As well as in the North Sentinel Island, human civilization governs itself, but at the same time they are part of a conglomerate of stars with an owner and a name. We could be inside that enormous zoo, but we do not realize it. A sufficiently advanced civilization could study all the time what happens in our solar system and precisely what happens on our planet just to see how the human race evolves. And we would not be able to notice since they do not want to contact us. They only want to observe and study us without interrupting our evolution as a species, just as we did with the Sentinelese. If the Earth were a zoo, then would we be like the Sentinelese, a civilization being observed, studied, and possibly even protected by that much more advanced civilization that does not want to come into contact with us for our safety? Could it be that just as we have diseases that could decimate the population of North Sentinel Island, an extraterrestrial race could have diseases that could decimate the entire human race? Alien police scenario of the Fermi paradox. Predicting what technology will be like in a century or even thousands of years is a game of educated guesswork. For example, during the American Civil War, no one could have foreseen that a century later the atom would be tamed and nuclear weapons with the ability to end civilization would exist. They just had no foundation for making such a prediction. On the other side, the notion of traveling to the moon was on the table, thanks to the efforts of Jules Verne, who published From the Earth to the Moon in 1865. He anticipated humanity would travel to the moon someday, but he couldn't have imagined that it would happen barely over a century later. Because we have evolved so much in such a short amount of time, it is possible that we still have a long way to go in terms of technical growth, both with things we can predict, such as Dyson swarms, and those we cannot predict. The latter is the eerie aspect of technology. Entire hypothetical technologies, such as the entire consequences of nanotechnology, remain mostly unexplored by humans. We've started the adventure, but we have no idea where we're going. And then there are completely unknown future technologies that we don't even know the science for yet. We still don't know a lot of the science that is hidden from us. Huge gaps exist in our understanding of the universe. The best example for this would be that general relativity and quantum mechanics do not line up, even though they are both correct. This tells us that there are missing pieces of physics that we still need to discover. We have some puzzle pieces, but we don't know how many more are missing. This might imply that there are really harmful technologies in our future that we have not yet imagined. While traveling to the moon was predicted in the 1860s, the nuclear bomb was not. That requires a trip back in time to 1914 and H.G. Wells' classic The World Set Free. So the concept of nuclear war, humanity's greatest technical, existential danger, emerged seemingly out of nowhere and very quickly. This might occur again. But thus far, we've only done things that have an impact on the Earth. It is possible that there are technologies out there that are so hazardous that they may destroy entire galaxies, if not the entire universe. The answer is that it may be. A lot of theories have been made in regards to galaxy-threatening devices. The most famous example is the paperclip maker, in which someone constructs the machine with a specific purpose, to produce paperclips, and it escapes and begins converting the entire galaxy into paperclips. Another example would be self-replicating probes with no limit on reproduction that actually consumes the galaxy, transforming it into copies of themselves. Another type of cosmic danger would be generalized, very powerful artificial intelligence, which may choose to eliminate all biology, enslave it, or change it wherever it finds it. Then there are the mysteries of the cosmos itself. As I said in a previous video, the universe may not exist in its lowest potential energy state, and if it ever did, it would send out a shockwave at the speed of light, destroying all matter in the universe in its current form. Is it feasible, given a comprehensive enough understanding of physics, for someone to do the incorrect experiment and set it off? The answer is probably no, but it's in such a confusing region of physics that it can't be ruled out just yet. This creates a dilemma. How do you prevent a civilization from posing a cosmic danger if it is capable of doing so? This brings us to what I refer to as the alien police scenario. This is sort of a variant of the zoo hypothesis, but it's more specific and speculative. Once you realize such far-fetching hazards are feasible, it makes logical sense to police the galaxy, and anybody coming into contact with these technologies must either be warned not to do so or be forcibly stopped. Consider it this way. You're sitting on your porch, taking in the scenery. You'll see police cars patrolling the area on a regular basis, but unless you're clearly breaking the law, they won't pay attention to you. They simply pass on by their patrol. However, if you were taking your neighbor's barbecue and dragging it back to your property while your neighbor yelled for the cops would stop and you would stop stealing it. This might be how different galaxies might work. There are police investigations taking on the inhabited advancement of growing civilizations. They stay concealed, much like a traffic cop, until they notice you doing something or reaching a level of technology that necessitates their involvement for the sake of the whole galaxy's safety. Your personal safety, on the other hand, may be of secondary importance. If you choose to do something that will cause your own extinction, that is not the galaxy's concern, and you are free to do anything you want. If you go beyond that, you will be stopped. It's fun to imagine what this monitoring and intervention situation may look like. To inspire the phrase good cop, bad cop, there may be a combination of police investigations from various civilizations, some forgiving, some not, and it all depends on who gets to you first. Alternatively, if the first probe establishes peaceful contact and issues a cease and desist order and is disregarded, the second probe becomes more aggressive. If you don't stop, you'll be exterminated by a hostile alien civilization police probe. Or it may be a single, all-powerful probe launched by all civilizations working together to enforce galactic safety standards. It might easily destroy or downshift any dangerous civilization. These are some possibilities that can be possible. Does it seem like nations and politicians on Earth already? Another possibility is that if the offending technological development is the result of a conflict on a planet, the probe may act as a mediator in the dispute to avoid the development entirely, and then adopt a trust but verify stance with the civilization, knowing that there is always a death probe sitting in their star system. Another scenario here approaches it from a different angle. Aside from technical surveillance, a police investigation may have another purpose. It might also serve as a kind of defense. Why, if such a probe was discovered to be considerably more powerful than anything required to destroy or reset your civilization? It can prevent you from creating weapons to match it fairly early on, so there must be another reason. The question then becomes, are those weapons present for your own protection? Then you must consider what it is protecting you against. These are always the creepiest Fermi paradox situations, since they imply the existence of something malicious out there, and you need to be protected from it. The probe becomes a sentinel, waiting for anything from the depths of space to assault, at which point it will spring to life to protect you. Perhaps the galaxy has vanquished that danger throughout the period the probe has been around, which might be millions of years, or vice versa, and the armed probe's creators are long gone, and the probe is no match for this enemy. Or the probe may be more than a match for the enemy. Consider the first civilization in the galaxy making errors and understanding the perils and rewards of millions of years of technological advancement. Imagine they've seen it all, battled other civilizations in technological progress wars, and eventually become the galaxy's police force. Perhaps this occurs in all galaxies with sentient life, with one overlord civilization developing and managing the rest, not in their own internal affairs, but in interplanetary affairs. To remove the risk of violence, maybe all communication between planets is handled by this safety police. The truly terrifying aspect about this scenario is that we may be in it without even realizing it. It's highly unlikely, but not zero. Another possibility is an idea about von Neumann, Benford, and Bracewell probes. Any of those ideas can be applied here for a police probe. A probe may essentially perform two things to watch us. It could do it passively, say from anywhere within the solar system, or perhaps more ideally from the moon's surface. If it was suitably disguised and displayed only monitoring equipment smaller than the greatest resolution of our cameras, it might remain concealed eternally, merely waiting for us to violate galactic law. The second possibility is that it is deliberately monitoring us far more closely, and we have mostly dropped the ball and missed it. Such a probe may create atmospheric probes to see into the atmosphere and observe our actions more closely, or could conduct through scientific investigations of all life on Earth. People have frequently stated that humans would be like ants to an alien civilization, and they would not be interested in us. But the truth is that we're fascinated by ants in two ways. For starters, there are scientists on Earth that specialize on ants, and we've amassed a vast amount of knowledge about them. Ants are fascinating, to the extent that humans keep ant farms for educational and recreational purposes. However, we also interfere when we discover ants in places where they are not wanted, such as the kitchen. If ants go too far, whether consciously or not, the ants must leave. As a result, even if we aren't at an extraterrestrial civilization's technical level, they may be quite interested in us. And this is where the unidentified aerial phenomenon, or UAP, comes into play. The most likely avenue to an extraterrestrial explanation for the UAP phenomena is the concept of a probe sitting in the solar system watching us and creating smaller atmospheric probes. Now, a point to note here that these are matter of phenomena, plural, and there might be multiple explanations to their origins. Some may stay unknown for the rest of time, but at least there are attempts like the Galileo probe to try to figure out what's going on. However, there is a reasonable explanation for an extraterrestrial presence here. The question of whether or not there is one is quite different. But if that's the case, one of their motive for us being here is a police operation. Zombie apocalypse. Fighting for survival. Fermi paradox solution. Welcome to a journey beyond the stars. Today we dive into the speculative realms of the zombie universe hypothesis, a wild yet intriguing idea that may shed light on one of the greatest cosmic mysteries of our time. Now you might be wondering, why zombies? Well, as we've seen in countless films and TV series, the origin of zombies is often shrouded in mystery, leaning more towards fantasy than science. But what if we were to explore some clever pseudo-scientific notions? Could we find a plausible way for the dead to rise, not just on Earth, but across the cosmos? Could this eerie concept of a zombie universe hold the key to the Fermi paradox? Let's embark on this journey and try to redefine our understanding of zombies. No longer mere products of a viral outbreak or a mystical curse. We shall envision them as biological entities driven by nanotechnologies. Nanotechnologies and zombies. In the not-so-distant future, the mastery of nanotechnologies becomes a reality, unlocking a Pandora's box of profound implications for the very essence of humanity. Picture a world where one can dive into the intricate realms of the human body, navigating down to the cellular level with the precision of a cosmic explorer. At this infinitesimally small scale, the potential to manipulate the patterns of our thoughts and feelings becomes not just a possibility, but a chilling reality. In the wake of this technological leap, the specter of George Orwell's 1984 takes on a new, more insidious form. A dystopian scenario unfolds where a cynical and power-hungry individual, or worse yet, a despotic monarch, seizes control of these nanotechnologies to infiltrate our brains. No longer is it a matter of external surveillance or propaganda. This is an invasion at the very core of our consciousness. The consequences are dire. Minds become pawns in the hands of unseen puppeteers, rendering the concept of freedom of thought utterly obsolete. It transcends the realm of propaganda. It's an intimate violation of the sanctity of individuality. The term zombie takes on a new meaning, not in the traditional undead sense, but in the sense of beings whose actions are manipulated from within. Their autonomy stripped away without them even realizing it. This nightmarish scenario threatens the very fabric of what makes us human, our ability to think, feel, and act autonomously. The once vibrant tapestry of human souls is at risk of literal destruction, as our zombie minds are now coerced into performing actions against their will, all orchestrated by an unseen force wielding the power of nanotechnology. Yet the grim reality remains in the realm of speculation. For now, we are distanced from such a dystopian future. However, the warning echoes. The march of technology is relentless, and the ethical boundaries of what we can achieve are ever expanding. As we peer into the uncertain future, the line between science fiction and potential reality blurs, and the cautionary tale of a world where humanity becomes mere characters in a creepy game becomes a stark reminder of the responsibility that comes with unlocking the secrets of the smallest building blocks of life. Animal instinct. In light of these considerations, it is a profound blessing that we as humans possess the ability to think with our brains and act upon our thoughts and instincts, an attribute shared by all Earth's creatures. Take, for instance, the bear. Bears stand out as an extraordinary example, ranking among the most intelligent beings on our planet. They exhibit remarkable qualities such as caring for their offspring and even showcasing problem-solving skills, as seen when they open closed jars to access the honey within. When confronted with something unusual, like a hidden camera capturing their presence, they demonstrate curiosity and attempt to comprehend the purpose of the foreign object. Nevertheless, a crucial point to emphasize is that despite their intelligence and endearing demeanor, bears, like all animals, operate primarily on instinct. Drawing a parallel with human behavior, if a bear is hungry, it will instinctively pursue its need for sustenance. In this aspect, we humans share a fundamental similarity with our fellow inhabitants of Earth. Now envision a scenario where bears could be manipulated by external forces. An entity in control could suppress their natural instincts, eliminating the potential danger they pose to humans. However, a malevolent influence could also magnify those instincts, turning the quest for human flesh into the sole purpose of their existence. In such a circumstance, these manipulated bears would cease to be authentic bears, transforming into mere puppets or zombies, manipulated by the sinister forces of nanotechnology. Indeed, even though the scenario of nanotechnological mind control seems unlikely in our current reality, contemplating its implications allows us to recognize the ethical and philosophical challenges that might emerge with the advancement of technology. Furthermore, as we gaze into the vast cosmos, it's intriguing to ponder the possibility that intelligent life beyond Earth has already traversed the threshold of technological evolution, reaching a point where such scenarios are not only possible, but perhaps a part of their daily reality. In this speculative narrative, the dreams of extraterrestrial civilizations, once brimming with creativity and diversity, might have transformed into a haunting reality. Imagine a cosmos where the aliens we've often envisioned are no longer the architects of their own destiny. Instead, they've become mere vessels, manipulated by the whims of a tyrannical force that seized control long ago. The rich tapestry of their civilization, with its romantic stories, music, and culinary marvels, has been erased, leaving only the oppressive will of a single or a handful of malevolent minds. However, the situation could escalate further. It's conceivable that each individual zombie is under the command of a centralized mind that dictates the actions of the entire collective. In this scenario, the extraterrestrial beings would essentially be manifestations of a singular consciousness, residing somewhere unknown in the vast expanse of the universe. Meanwhile, these cyborg zombies would be deployed on missions to explore new asteroids or planets, potentially with the sinister objectives of annihilating or assimilating existing life forms and gathering and squandering valuable resources. The early civilization. Both the conventional zombie hypothesis and the unified mind hypothesis could potentially exist at this very moment in the universe, yet our encounters with them remain elusive. This is precisely where the Fermi paradox takes center stage, demanding an answer to the haunting question, where is everyone? Now let's delve into a cosmic thought experiment. The widely accepted truth is that the universe is in a state of expansion, a process unfolding over vast timescales. In the course of billions of years, the gaps between galaxies will widen, rendering the cosmos unrecognizable from its current form. Simultaneously, galaxies themselves will undergo transformations. Collisions will give rise to entirely new galactic compounds, a phenomena anticipated in the impending collision between the Andromeda Galaxy and our Milky Way. As we fast forward the cosmic clock, the universe will adopt a redder hue. This change results from the demise of the youngest, largest, and blue-hued stars, consuming their fuel at an accelerated rate. Galaxies will predominantly be tinted red,
challenging any surviving populations to adapt. In the quest for sustenance, resources become paramount. Given that red dwarfs are less than ideal for sustainable life, advanced civilizations, now masters of intergalactic travel, embark on a mission to conquer other territories. If any of the earlier discussed zombie hypotheses were to materialize, we might find ourselves in a universe teeming with zombies, traversing galaxies to plunder resources from planets, asteroids, or even black holes. The seemingly silent and tranquil universe we perceive today would be a distant memory. In a twist that amplifies the eeriness, an attempt to explain the absence of observable civilizations could lead to the unsettling realization that we are an exceptionally early civilization. What does this imply? Scientists remain uncertain about the origins of life, but it's acknowledged that at a certain point in the universe's history, a pivotal event occurred giving rise to prokaryotes on Earth. Subsequently, the emergence of eukaryotes transformed our planet, while the process leading to life as we know it took approximately 1.5 billion years. What if this time span varies on other planets? What if we are among the earliest life forms, patiently awaiting the emergence of other civilizations elsewhere in the universe? In this scenario, we could be the contenders for one of the elder civilizations in the cosmic tapestry. We could find ourselves akin to zombies, seeking methods to prolong our existence while contending with emerging civilizations that are destined to remain stunted, unable to flourish and explore the cosmos, as we either assimilate or annihilate them. Alternatively, we might have become a distant memory, and the cosmos is teeming with civilizations that bear little resemblance to us. These advanced beings acknowledge that the universe was once the domain of another species, and the inevitable fate of every entity, including zombies, is eventual demise. Conceivably, our planet might have left no discernible traces, obliterated by the tumultuous fury of the sun as it reached the end of its life. On the other hand, we might have devised ingenious methods to leave behind a testament for future civilizations, a testament born out of human endeavor to preserve our memory throughout eternity. At the very core of human civilization lies a discovery that has shaped our existence: fire. Its significance extends far beyond the warmth it provides or the food it cooks. Fire has been instrumental in everything from forging metals to generating energy. It enabled us to adapt to colder climates, fend off predators, and eventually build societies. From the earliest blacksmiths fashioning tools to the steam engines propelling the Industrial Revolution, fire has been the catalyst of our technological progress. But do we truly comprehend its full potential? And why does this matter in our quest for extraterrestrial life? The ability to harness fire is a unique trait intricately tied to specific environmental and biological conditions that may not be prevalent on other celestial bodies. The discovery of fire was a game changer for the fate of humanity, but it required something like oxygen. Oxygen is not just essential for life, it's crucial for fire. Earth's atmosphere reached its current oxygen-rich state through billions of years of photosynthesis, primarily by plants and algae. This process transformed the planet and set the stage for fire development. Oxygen supports combustion, which is vital for technological advances from cooking food to smelting metals. However, the presence of oxygen at the right concentration is rare. If extraterrestrial environments lack similar evolutionary paths, they might not have fire, limiting potential technological advancements. This rarity of breathable, oxygen-rich atmospheres may be a critical factor in the Fermi paradox, a concept that ponders why, given the vast number of stars and potential for life in the universe, we haven't yet seen any signs of extraterrestrial civilizations. It suggests that the conditions necessary for the development of fire, and by extension, advanced technology, might be exceptionally uncommon in the universe. The Carboniferous period, a crucial era for life on Earth, was characterized by extremely high levels of oxygen, up to 35%, compared to today's 21%. This oxygen-rich atmosphere led to frequent and large-scale wildfires, profoundly influencing the evolution of Earth's flora and fauna. The dense forests of the period provided ample fuel, while high oxygen levels made the environment particularly prone to combustion. This period showcases a delicate ecological balance,
where too much oxygen could lead to destructive wildfires. Yet it was also a time when the foundations for complex ecosystems were laid. Such conditions could be exceedingly rare on other planets, making Earth-like fire-dependent technological evolution unique in the cosmos. These segments of Earth's history highlight the unique conditions that have supported life and technology on our planet, and underscore the potential rarity of such conditions elsewhere in the universe. This could be a pivotal reason behind the Fermi paradox, suggesting that civilizations capable of using fire and thus developing technology that could signal their existence to us might be exceptionally uncommon. The impact of fire on our technological progress is nothing short of profound. It's not just about warmth and cooking. Fire enabled early human societies to manipulate their environment in revolutionary ways. By harnessing fire, our ancestors could clear vast tracts of land for agriculture, fundamentally altering ecosystems to better suit agricultural practices. Moreover, the ability to smelt metal transformed societies, leading to the development of tools, weapons, and eventually machinery. This mastery of fire accelerated the advancement of engineering and science, laying the groundwork for modern technology. Without fire, the Industrial Revolution, powered by steam engines that relied heavily on combustion, would have been unimaginable. Thus, fire is not merely a tool, but a foundational element that catalyzed the rise of civilization as we know it. Its role in our history is a testament to its power and significance. But what about exoplanets covered with oceans? Can't life just thrive in the oceans in the absence of fire? Considering life on water-covered planets, the absence of fire poses significant barriers to technological advancement. In aquatic environments, even if intelligent life evolves, such as the sophisticated but arm-limited dolphins or the dexterous octopuses, the mastery of fire remains unachievable. Water inhibits the generation of fire by preventing the accumulation of sufficient heat, which is essential for combustion. This limitation restricts the ability to process materials like metals, which are pivotal in advancing from simple tool use to complex machinery. Consequently, civilizations in aquatic settings might develop along entirely different lines, possibly focusing on biotechnology or other forms of technology that don't rely on heat and combustion. This divergence in technological evolution once again highlights how pivotal fire has been on Earth. It suggests that the absence of fire could lead to a very different path of technological development on other planets. Considering all these factors, the rarer fire solution suggests that the conditions needed to harness fire are so specific and rare that very few planets might ever reach this stage. Thus, while the universe might be teeming with life, technologically advanced civilizations capable of making themselves known across the cosmos might be extraordinarily rare. This concept suggests that the ability to harness fire, a unique trait intricately tied to specific environmental and biological conditions, might be a crucial factor in the development of advanced civilizations. If the conditions necessary for the development of fire, and by extension, advanced technology, are exceptionally rare in the universe, it could explain why we haven't yet seen any signs of extraterrestrial civilizations. So, fire, as a critical milestone in technological development, may be more unique to Earth than previously assumed, providing a compelling answer to the Fermi paradox. The rarity of fire hinges on several stringent conditions. A planet must have sufficient oxygen, which itself depends on specific biological geological histories. It must have flammable materials, which are biological products, and it must have the climatic and environmental conditions that allow fire to catch and spread without extinguishing life. These conditions are so specific that they may seldom coincide in the universe, making Earth an extraordinary exception rather than the rule. On planets where these conditions do not align, the development of technology as we understand it, relying on heat, combustion, and metallurgy, could be severely limited or take a completely different path that might not produce detectable signals like radio waves or visible lights across vast interstellar distances. Thus, fire's rarity could fundamentally limit the emergence of technologically advanced civilizations capable of making contact or being detected by us. thereby offering a solution to why we find ourselves seemingly alone despite the vastness of the universe and its billions of stars and planets. This perspective encourages us to rethink our search strategies and assumptions about what forms a technological civilization can take. So fire, and the mere discovery of fire, could be a critical factor in determining the advancement of civilizations. However, let's not limit our imagination to just fire. Civilizations could potentially evolve using alternative energy sources like geothermal or tidal energy. The challenge remains whether such alternatives could support an advanced, industrialized civilization capable of space exploration or emitting detectable signals. Geothermal energy, for instance, exploits planetary heat and could be particularly accessible on volcanically active worlds. Tidal power harnesses the kinetic energy of water bodies, ideal for water-rich planets. Solar technology might involve ultra-efficient photovoltaic systems or artificial photosynthesis, mimicking or enhancing natural processes to create sustainable energy sources. Furthermore, biochemical processes could lead to unique bioenergetic technologies, where organisms convert organic materials directly into usable power. Finally, electromagnetic energy from natural planetary fields could offer another untapped resource, suggesting that civilizations might exploit these forces directly to power their societies. Each energy source could lead to distinct technological advancements, potentially unseen and undetectable by our current methods, emphasizing the diversity of possible evolutionary pathways in the cosmos. It would then follow that SETI and other alien hunting strategies would be under some pressure to reconsider their game. We shouldn't be looking out for fire signals or other traditional signs and markers of technology. Rather, we should look for non-fire-based markers of civilization, or better still, for something totally different. This may involve the development of new sensors and instruments that can detect such alternative energy uses. For example, sensing weird electromagnetic patterns or other atypical chemical signatures in atmospheres. Reformulating our frameworks to include those civilizations that can, from radically different technological paradigms, find a way for progress could open new lines of discovery. All of this broadens the search criteria, making it more likely that we would find a civilization with characteristics significantly different from our own. Great Filter Theory. The Great Filter, or Great Filter Hypothesis, is a proposal by researcher Robin Dale Hanson of the University of Oxford, who proposed that in the development of life in the earliest stages of abiogenesis to researching the highest levels of technological development, there is a barrier that makes detectable extraterrestrial life extremely rare. This hypothetical barrier is the Great Filter. This hypothesis would tell us that something must slow down or reduce the number of civilizations that develop to be as technologically advanced as humans. This threshold of probability, which could have existed in the past or after human extinction, could function as a barrier to the evolution of intelligent life or as a high probability of self-destruction. The main takeaway from this argument is that how much easier it was for life to evolve to the stage humanity is at today would mean that the Great Filter is something humanity will face in the future, and what will end our civilization, like a nuclear war. This would mean that all species that manage to develop nuclear weapons eventually end up self-destructing, which is why we haven't found them, because every time one reaches that degree of technological advancement, they end up annihilating each other, and human civilization could be next. The role of viruses in evolution. Although many scientists suspect that the Great Filter could be in the future, many others conjecture that this hypothetical Great Filter could be found in the past. How could this be? To understand this, we must consider everything that life has gone through to get where it is today. Some studies suggest that life on Earth could have emerged about 4 billion years ago, shortly after the Earth formed. This tells us that once all the conditions for the formation of life are present, it does not take long for it to appear. If life takes a long time to appear, then it would be subject to how long a star can remain on its primary sequence. But if life actually appears very soon after a planet forms, this could not be a Great Filter. In other words, the Great Filter would have to happen after the first living things appeared, perhaps in something that caused life to develop into what it is today. The answer could lie in viruses, no less. In nature, we can see that viruses are found practically everywhere. There is the virus of rabies, Ebola, smallpox, etc. All viruses have different characteristics, but if there's one thing they have in common, it is that although they share many similarities with living beings, such as the ability to replicate and evolve, they lack other vital characteristics, such as their metabolism and the ability to carry out independent cellular functions. That's why most scientists do not classify them as living beings. But if viruses are not living beings, then what are they? They are what they are, viruses, organisms that look like living beings but are not. They attack living organisms, feed on them, and reproduce by taking advantage of the DNA strands of living beings. But curiously, they are not living beings. It seems that viruses are chemical organisms that evolved completely separate from living beings, and that, in a way, they are opposed to life since viruses can eradicate living beings. However, despite the fact that viruses are harmful and it seems that their only function is to destroy living beings, could it be that viruses are also the reason why the living beings of the planet have managed to develop so much? Think about it. Without viruses, the first microbes that appeared on the planet would not have had any threat. Nothing that would endanger them or force them to evolve very quickly. But when there was the threat of viruses, living beings had no choice but to evolve very quickly, so that viruses would not exterminate them. So the existence of viruses on Earth could be a viable solution to the Great Filter Hypothesis. In this way, it would be possible that microbial life is prevalent in the universe. But without viruses like those on Earth, these extraterrestrial life forms are not pressured to evolve quickly. Even if they manage to evolve due to changes in their environment, there is no guarantee that they will manage to develop to a certain degree of complexity, or that they will develop technologies like the ones we humans develop. But how possible is that viruses were the driving force behind the development of the enormous diversity of living beings on the planet? Some scientists think viruses introduced genetic information into living things in ways that could have helped shape the genomes of life on Earth. An example of this can be seen in humans, who, thanks to the various viruses that have hit us in pandemics, now have better defense against them. If this happened with all living things on the planet, it would mean that viruses somehow help the evolutionary process of the species. However, evolution can also benefit from mutations, which do not depend on viruses. This would imply that the absence of viruses should not be an obstacle to developing intelligent life on other planets. Or should it? Retroviruses and human development. A recent study by a group of scientists led by Tanay Ghosh of the Cambridge Labs Institute of Science investigated a substance called myelin and its importance in developing human intelligence. Myelin is a mixture of proteins and lipids necessary to insulate nerve axons. It resembles the insulator of an electrical wire, but is obviously much more important since it allows the electrical impulses of nerve cells to be up to 100 times faster. They also observed that the myelin coating makes neuronal fibers thinner and longer, allowing nervous systems such as those in the brain to be much more efficient in response speed and processing. So evolutionary, a species with this protein would react faster to danger, could develop better hunting strategies, and would generally be more intelligent than those without. But what does the myelin have to do with viruses? The scientists in charge of the research discovered that at some point in history, a retrovirus infected vertebrates with jaws. In response, they activated the production of myelin, which helped defend against that virus. They helped them develop more complex and faster brains like humans. It seems that at some point in the past, during the development of the diversity of species that inhabit the planet, this virus infected different animals, activating myelin production in different animals around the world as a kind of convergent evolution. The interesting thing is that the person responsible for this was a retrovirus. Retroviruses are viruses composed of RNA and are characterized because they can make copies of their own DNA and embed that genetics in their host, passing that characteristic from generation to generation. This would mean that without this retrovirus, the human race would not have developed the intelligence and skills that led us to develop the great civilization we are today. It's interesting how today many viruses take the lives of thousands of human beings, such as smallpox, Ebola, or rabies. But if it were not for the existence of viruses, we would not be here.